Hello, yeah. Today I'll be presenting about Signal apparently because Anthony wanted me to do signals. So before I jump into the presentation, who am I? Malik. I'm the ops lead. I'm from Saudi Arabia, senior BSMS. So this is my last semester. Interest, the stuff. Talk to me, please. I like talking to people. So signal. What does signal mean? It's not the signal of the wiggle or like wireless or anything of that. It means sorry. Anthony's last name, because I cannot pronounce it, gonna never actually listen. So, what is the story behind that name? So, I saw this newsletter saying like Malik gonna present on Signal, but I didn't remember me signing up for Signal. So I went back to my DMs and I checked. Anthony DM'd me in Signal saying, Malik, what is your talk called? Sorry, I just did not see your message. I was in class. My favorite dinosaur, Velociraptor, is my talk. And he messaged me in Discord as well. And I said, check Signal because I sent you the name there. And he did go Signal. So the actual topic is my favorite dinosaur, Velociraptor. So this is gonna be so fun. We're gonna talk about dinosaurs and we're gonna have all of sort like the history about them and like the beginning of dinosaurs. So we have dinosaurs. Who likes dinosaurs as me? As me? Oh, everyone. Cool. Awesome. Yeah. So we're gonna talk about dinosaurs, but we're switching gears from those dinosaurs to this one, Velociraptor. So this is actually cool. What is Velociraptor? Beside being a dinosaur, Velociraptor is an open source tool that is used for digital forensics and incident response. It was developed by Rapid7, which is one of the best tools that I have ever used in any like scenarios of like digital forensics or IR in general. And its cause includes the ability to query system information. So it just create a system to be like a database that you can query about stuff, running processes, running ports, any usernames, registry keys, hive files, shell bags, the list goes on. And you can customize all of those to even inspect the binary themselves. So I want to look up for a binary that has specific signature. I can actually make a query in that using Velociraptor and it will just go and actually do it. So what are the use cases for Velociraptor? It can collect, monitor, and hunt. So after like you have all of your asset added to the like the server you have, and you can actually collect like run command against them, collect those logs, and monitor those logs to define which is normal, which is not normal, and then you perform your threat hunting to understand if there is anything that's abnormal and anything that you can actually catch, or anything that you can actually record or like open an incident based on. So how is the architecture looks like? This graph is like from their documentation. So credits to them. I forgot to include the source. But we have the Velociraptor server, which is a default server that you will have, and then you have assets, which is the laptop in the top right corner. Yes, it is top right. Top right corner. Then you have a persistent communications (CNC), which is command and control. So this can be used as command and control eventually. And then you have the admin where the admin log into the server and the server just send commands to the assets. The asset will give you the results back and you can actually perform like analysis on those hunted like collected data or information. So natively, Velociraptor supports like the Mac OS, Linux, and Windows natively. So you will not have a problem depending on like the environment or the system that you're trying to get. It should just work, and it follows as we just saw server client model. And server send the query, client do the heavy lifting or do the whole work, and just actually get the results back to the server. And the end user or the admin or the analyst can just be able to see all the logs in the centralized place. So this seems a little bit redundant. What's the new difference, or why Velociraptor is actually making any difference, or like why we have Velociraptor in the first place? Uh, but before we jump into that, let's talk about the architecture or like the design, like the components of that. We have a client, we have a front end, we have a GUI, and we have an API. The client is the asset you're trying to manage, and we have the front end, and the front end is not the actual like GUI or like the website that you go to. The front end here, the author of this tool or the people who did that, Rapid7, they meant the actual server, the back end. I don't know what they call it front end, but they are referring to the back end because the GUI is the actual front end because it's the website. It's weird, but that's what they meant. And you have an API. So here's the difference. Velociraptor supports an API. That API can help you automate a lot of your tasks, a lot of your job, anything that you want to do, like investigation, routinely, like threat hunting processes, just IR processes, digital forensics. So when you have an image, I know I want to run X, Y, and Z stuff, and every image just to build an overview of the case itself. So I can automate that with the API. That's where like Velociraptor really gets into play. But it's like still a powerful tool nonetheless of the API. All right, so we talked about Velociraptor and we did like query, how we're gonna query all of that information, how we're gonna collect all of those information, how we're gonna monitor all of that. Velociraptor uses something called VQL, which is Velociraptor Query Language, which is, we all know it's very, very similar as SQL, which is like SQL, even in the name itself and in the syntax as well. Query language that enables sellers to perform complex queries on queries on collected endpoint data. And VQL has a rich set of like built-in functions that you can utilize. And that built-in function can actually be libraries based on the system itself. So you can get specific information based on the host and that based on the operating system itself. VQL syntax is very, very, very similar to SQL. And that will just like make it the baseline of everyone. If you know SQL, you'll be able to know how to write VQL. And even if you don't know SQL, SQL is pretty straightforward to understand, and you can just customize as you want. So we will just pick it up on the fly, and the learning curve for that will be more efficient for like anyone who's new to it. So let's look at an example. As you can see, we have a select statement here from plugin where X. What does all of that mean, Malik? I'm not sure I understand. So let's break this down. So we're gonna select, and that is the column selectors. So we're gonna select column X, column Y, column Z from VQL plugin, and that can be different million of plugins. All of that is documented in their website. And after that, we're gonna have a filter condition where we're gonna filter based on X equal to 1. As I mentioned in the beginning of this presentation, Velociraptor just query everything as some sort of database. So when you query information out of like plugins or like tables, you should think of the system, the whole system, like a giant matrix of like databases. So and you just pick what you want and match them with what exactly you want. You're trying to figure out. So here's some example. The first one in the middle. Let X select from info and select from X. So wait, I think I have a double select star from X. Oh no, yeah, cool. No, that's right. So we're gonna select everything from information, and information is that like a default plugin, information about the system itself, and we're gonna sort that in the variable, it's what you call it, like X, and that will help us to like write multiple nested queries, and all of that information can be used to expand like your visibility on the system itself. On the second example, we can see in the top right corner, select PID and name, and we have now a nested select. So for each process, we're gonna select another process from that so that we can get the parent list for that, the parent PID of that process. So from PID, we went to PPID, and we actually know where's the parent of each process, and then we can just display it to the end user. So it can be nested together. They can be assigned to variables, and they can be complicated as the one in the bottom, which is like from artifact to sys internals. Just give me auto runs where the category is a service and launcher string contain this string. It can be like complicated, and you can just build a huge, massive files of all of that information, which we will see in their documentation in a bit. Okay, so Malik, you talk about like this new cool tool called Velociraptor. Why should I care? I'm here more talking about a project that's called RIT-SIG. And RIT-SIG is not RIT-SIG us, but this is, before I jump into the project itself, I want to give credit to Brad, Max, Startup, Smash, Ishan, and myself. This was one of our classes projects we worked on, but I will focus on the part that I did in the project and why I think it's cool. So what is RIT-SIG? RIT-SIG ingestion tool for standardized extraction of computer artifacts. Does anyone want to give a guess who came up with this name?
Max Fusco.
Of course. Max came up with that name. He's like, yeah, we're gonna name it RT sake, and he just like came up with acronyms. He reminds me a lot of Anthony, like Signal, right? He came up with that too. All right, so this is RIT6. This is the tool we worked on. It's comprised like a lot of good tools like Go, React, Velociraptor itself, Podman. Max just did a great talk on containerization, and I did one previous last week or the week before, I can't remember, about Podman and why you should use Podman instead of Docker. So let's have an overlook of the architecture. We have Velociraptor 7 in the middle. We have a React JS server. We have a Go API like template to template all of those queries. And then we have a Podman containers, which are running some stuff, which we'll discuss in a minute. And we just like have a communication. And this is the overall project structure. As I mentioned again, the Velociraptor has an API. So we said, okay, we can automate that API. And Brad said, okay, I'm going to use Go to do that. Then Ishan said, I'm going to use React.js to build the front end for that. And me and Sma just worked on the Velociraptor and the Docker containers. And then Max worked on the reporting side of things and gathering all of the information using LaTeX to build a report of like the digital forensics. And it's going to be like automated DFIR. So just a quick recap, what is a Podman? Podman is a daemonless open source Linux native tool designed to make it easy to find, run, build, and share deployed application using OSI, which is the Open Container Initiatives, and container images. The key feature does not have a single point of failure, can run rootless, which is focused on security side, not like Docker where you have to run every container as a root, but this you can just run it as the regular users and prevent like work on the principle of like least privilege principle, so you cannot give anyone root access to your box. Follow the same structured concept as of Docker, and it's open source at the end. We love open source. So why did we containerize this project? First of all, separation, easy to scale, lightweight. Yeah, that's the word. Lightweight and easy to replicate. All of that information, all of these like features we wanted in our project, so that's why we did go with containerization. Now we have a container, we have a Podman container, we're trying to add that to Velociraptor. So how are we gonna do that? So first of all, we're gonna run any container, can be done using like a Docker compose file, and copy the client configuration, and then obtain the configuration file or like the binary itself from Velociraptor server, and also Velociraptor client, and attach the client, and the rest goes on. But we will look into that in details now. Before we look into the details, we were like the main objective of this project was to do analysis on dead disk images. And dead disk mean a system that you already acquired the image for and you're now trying to do analysis on. So I have a Windows machine. I would like to investigate that machine, and it was like been under attack or anything like that. So I will just go on and see the system itself and get that image. And then I would like to do further investigation on that image. And I want to do that using Velociraptor. So how I'm going to do that, I'm going to create a Podman instance, and then I'm going to mount that image to it and just run Velociraptor commands on it and make sure that I can get the output back to what I wanted. Does anyone see the main project idea now here? Have a disk image mounted to a container, and then that container can tag to the Velociraptor server, and from the Velociraptor server, the admin or the analyst just run commands. It's just like a chain of like hierarchy or whatever you want to call it. So why did we go with Docker again, or like Podman? Because we want to separate each image from each other. We want to like create like everyone to be like containerized, and everyone like can be separated. We can easily to replicate them, and it's gonna be lightweight. So we have to save resource on our system, because imagine you have an incident of like 50 images and you want to do all of them at once. Then if you're gonna spin up a VM for every one of them, that's gonna be huge. So disk image, again here, this dead disk image, imagine a done, yeah, okay, I was trying to say. So a dead disk is just like a system you get an image from, and that system is not powered on. Then you have to find the offset of that disk, and then you have to podman volume mount. So you mount it, and then running the mount command inside podman. So you can see some examples in here, but we will look into that in details here. How to use a dead disk with Velociraptor. That was the tricky part of everything. This is the hardest part in the job that we did in this project. Fun facts, we had to reach out to the Velociraptor developer because the lack of documentation. Documentation is key for every project, and that's why we're telling you before you write like the initial code base for your project, make sure to have some outline documentation and just build them as you go through the project. So remapping the images, remapping, what does remapping mean? So now we mounted the dead disk image to a podman container, but Velociraptor commands are still being run on the container itself, in the container's file system, not the dead disk. So you have dead disk B that has user Malik, and dead disk, not the actual system, the actual system disk has a user called ops. And when I will run Velociraptor command, give me all the users, it will give me ops user, it will not give me Malik, while Malik is the user that of interest that I would like to analyze furthermore. So remapping is actually tricking the podman container to thinking that the mounted drive or the mounted disk is actually your disk. So when I ask you to give me some information, go to that mounted drive and give me that information back. Don't give me from your local system. And that is what is like remapping mean. A config file define the remapping rules, and that can be different from Linux and Windows, depending on your system. And we're going to show both example in a minute. And then after we have mounted that, we remap the config files or remap the file system. We're going to just config override. So we're going to override the configuration. And we can actually, when I ask the podman container to give me some information, it will go actually to the mounted drive instead of going to the local disk. Okay, so here's where things get tricky. So bear with me, please. And if you have questions, just throw them away. Linux did disk image, and now we're gonna see a lot of codes. First of all, to get a Linux disk image, a did disk image, we have to build a Docker container, which is same as Podman container. In my Podman presentation, I mentioned that Docker file can be run by like Podman or like just Docker itself. They are like the same thing, the same structure and everything, but we're just gonna use Podman for sake of security. So we're gonna define what is the base image, as just Max showed us like an hour ago or so. We're gonna define the from Ubuntu. We're gonna use a Ubuntu image. Then we're gonna copy the client config YAML, and then a helper script that we made, and it's called attached Linux client. And we're gonna copy the remapping config that we generated, and we're gonna solve some like default or like needed binaries or needed information. And after that, we're gonna cmd or start the container with the command of attached Linux client and bin bash to keep it like up and running. That is the Docker file for Linux. Now we just saw the Linux attached client and what's that contain. As I mentioned before, we need to figure out the like offset of the disk itself, so we can actually mount it appropriately, because everyone knows that when you do like fdisk or like blockcat or like df-h, no, probably df-h will not show that, but fdisk will show you like different sectors, the boot sector, like the root sector, and all of those information. And we would mount those information. We want to get only the sector that has slash, which is that has the information for our system, for our like box or our machine. So I'm gonna find out the offsets. We have some documentation here. You need to change the offset. What you're doing is actually the first part that we wrote documentation while we go, which was cool. And then we found the offset, and we're just gonna just copy the image, and it's gonna be like a variable container name, and we're gonna mount it to mount data. And then we're gonna run Velociraptor with the config that we generated from the server, and we're gonna override the config with the Linux remapping, because we wanna remap into tricking that podman container of believing that the mounted file or the mounted disk is actually its local disk. It's not like separate. So now we looked into Windows. How is that can be different, right? So easy. This is so tricky. So we're gonna run a dead disk image Windows analysis on an Ubuntu container that's need to be remapped back to Windows. I don't know. It's tough, but look, we're gonna explain that now. We're gonna start a Ubuntu container. We're gonna mount the same configurations. We're gonna have the client config. We're gonna have the Windows client attached, and we're gonna have the remapping, and we're gonna source the same like essential binaries and information, and then we're gonna attach Windows client, and we're gonna see how is that different. Windows. For Windows, there's a specific flags to analyze Windows disks, did disk images, but there's no specific flags for Linux. So if you can see in the Velociraptor, the second command after the comment, this one here. Yeah. If you can see in this one, oh, sorry. We can just add the flag and we give it the image and then we give it the remapping file and then we're gonna connect ourselves to the actual server with our configuration overwritten, and we have the remapping configuration. That's how you create like a Linux system. This is how you create a Windows system and how you mount like different images to those containers. So after all, we're trying to put everything together. This main project was like aimed for automation, and we're gonna do that by a Docker compose file. This was later on like automated with using variables and stuff, but this is just like a proof of concept to make it easy for readability purposes. So we're just gonna define a Docker compose file as Max just showed us how, and then we're gonna discuss some services. And the first service is called Linux that define a container name, which is gonna be Linux client, and then we're gonna build it. And the Docker file name is actually Linux Docker file. And we're gonna set some host name and volumes. We're gonna mount the actual image that is of interest that we wanna analyze in our process or like our investigation. And we're just gonna have a TTY true to be like we can actually go inside or have a shell on the container itself. Same goes for Windows. We're just gonna have to mount different images, a different like disk analysis. And if you can see the name of the images or like everyone participating like RISC, it's gonna be Orca and C line, which was like boxes from like the competition from RISC that we just dumped and we did analysis on to see what red team did, what red team didn't, and all of those stuff. That is a quick recap. I think that's like last slide. We have a Podman container that has a dead disk images on them, and they are connected back to Velociraptor server, whereas you as an analyst, you can run commands through the Velociraptor APIs and get information from the dead disk you just mounted. All of that project was like automated, so you just run one command and everything will just give you information. I will give you a report of like, yeah, here's what we found. Here's all the users. Here's all the commands you were run. Here's like the shell bags. Here's the link file. Here's some register information. And I think I can show you one example of the output. But just to sum everything up, Velociraptor is a great tool for digital forensic and incident response. It supports like being proactive to the system. You can actually have a shell. It's like a C2. It's like a red team tool, but it's like more advanced in more not red team way. Velociraptor is a great tool for digital forensic and incident response. It supports automation, easy to scale, open source, and it's really, really easy to set up. Like the setup of it is like really easy, but when we did go to the dead disk side of things, it was like, okay, the Velociraptor is not meant to be there, but you can do it with it. So that's why it's not like really clean how to do it. So that's why I did this presentation. Ability tools that automate the investigation of digital forensic artifacts can improve investigation outcomes by a lot. And this can save time, efforts, and even focus, and just like some of the stuff that you always run. So I found myself going to the digital forensic investigation. I run like these few commands. I get the outputs, sort those outputs, have it in a nice formatted, and then I submit that as a report or like initial overview. So if I can automate that process, why I shouldn't automate that? It will just take care of that information or take care of that part. Then I can actually have a look of what can I do else to speeding up the process. And thank you so much. Any question? And this will be my last RIT presentation on education. I will miss you all. Any questions?
You sure you don't want to start?
Okay.
What was your favorite presentation
Oh, for like all RIT
that you've done?
I've done?
Yes.
Oh, probably will be the Discord one I did. Yeah. Any other questions? Cool. I just want to have a quick look of the output, how it looks like. This is like the actual report that we did for that class because it was a class project after all. So when you just like run Windows sys user, it will just give you all the user, the SID, the MAC time, when was the user created. So we can use like if you been to like RISC or you participate in RISC in any way, you will recognize these names. You can like see SSH logins, what is like how did that like user attempt to log in, what is the method, was it like accepted or rejected, and what the time, what IP, and the full path and everything else. And you can see like bash history, you can see some command that were run on the system itself, and you can see like authorized keys. I don't know that team, I'm not sure which team, but they have a lot of red team keys in there. That's not really great. And you can see like all the files, like home folders and stuff like that. And with Mac time is actually important during digital forensic investigation. And this is how like the tool looks like at the end. And I will have a blog post going on my blog like real soon about like the part I did in this project, and I will try to expand it more. Finally, again, big shout out to Max, Brad, Ishan, Smash, and myself. We all worked on this project and as a group, and there's a lot more in that project, but I just focused on the part that I did in this. Thank you. Anthony, have a question?
Not a question, it's a statement. Love you, Malik.
I love you too, Anthony.